Okay, we'll answer some practice questions with this. Write the equation of hyperbola with foci at plus or minus 5, 0 and vertices at plus or minus 2, 0. So this tells me that this hyperbola has to be opening side to side. Okay, if the vertices are right over here on the x-axis, it's opening side to side. So I'm going to write this as x squared over some number minus y squared over some number equals 1. So if the vertices are at plus or minus 2, 0, then underneath the x is going to be at 4. Okay, vertices are underneath the x because it's x squared minus y squared, because we know it's going side to side. And then to figure out what goes underneath the y, I'm going to use the formula c squared equals a squared plus b squared. That relates my focus with what's underneath the x and the y. So I'm going to have my foci are at plus or minus 5, so that means that c is the square root of 5, so c squared is going to be 5. And I already have my a is 4, because that's 2 squared, and this is plus 1, so b is 1, so that means that underneath here is going to be 1. So there's my equation. Okay, number 6. Write an equation for a hyperbola with the vertical transverse axis, 16 units long. So that must mean that your underneath, so it's going to go x squared, it's going to go y squared minus x squared. So if the transverse axis is 16 units long, that means that my vertices are at negative 8 and 8. So underneath the y is going to be 64. And then if my central rectangle is 16 by 10 units, so if this is 16 units, and this is 10 units, that means that underneath here, this distance must be 5. That helps me with my slope. Okay, so remember that the slope, or the asymptote, is going to be change in y over change in x. So underneath the x is going to be 5, so it's going to be 5 squared. This is 25. So now the asymptotes would be plus or minus 8/5. Okay, down here, see if we can fill in the rest of this chart here. So if we know that the vertices are at 0 plus or minus 3, then this must be a vertical transverse axis. So in order to figure out the asymptotes, I need to figure out what my a and the b are. So I know that my foci relationship is going to be c squared equals a squared plus b squared. So in this case, I have 4 squared, which is 16, equals a squared, which is 9, plus b squared. So b squared has to be 7. So that means my asymptotes have to be y equals plus or minus the square root, or 3 is, this is already square rooted, so it's going to be 3, and it's on the y-axis over the square root of 7. And you can rationalize that x. I'm going to leave it like that for now. So your equation has to be, because it's a vertical hyperbola, it has to be y squared minus x squared equals 1. And since our vertices are at 0 plus or minus 3, that means that underneath the y squared has to be a 9. And then b squared is 7, so this has to be a 7 right here. So a common mistake that I see with people is that this the numbers underneath here do not dictate whether it's going vertical or horizontal. It has to do with this being y squared minus x squared. So this could be a 7 and this could be a 9. It's still going to go up and down. Alright, so this one, I know my asymptotes are 2/3 x, so this must mean that my equation, and it's vertical, it's going to be y squared minus x squared over equals 1. But I know that my change in y was 2, so underneath the y has to be a 4, and underneath the x has to be 3 squared, which is 9. So my vertices are going to be on the y-axis at 0, plus or minus 2. In my foci, I'm going to use c squared equals a squared plus b squared. So 4 plus 9 is 13, so my foci are at 0, plus or minus root 13. Okay, and the last one, the vertices in my foci are both on the x-axis, so that means that this must be going horizontal. So in order for it to go horizontal, it needs to be x squared over a number minus y squared over a number equals 1. So to figure out what the asymptotes are, I'm going to use c squared, which is going to be 6, equals a squared, which is, actually this isn't going to work. I'm going to have to change this. Because you can't have your, on a hyperbola, I'll change this number, you can't have your focal point be less than the vertices. Your focus needs to be in between here. So this couldn't happen right here.